let's pick back up in 4.7 where we left off. Okay, we're talking about inverse trig functions. And if you recall, inverse trig functions, remember an inverse function in general takes your x and your y and it switches them, right? Or it takes your input and your output and it switches them. So while normally we would say the sine of 30 degrees is 1/2, now when we say something like sine inverse of 1/2, it's at what angle is sine equal to 1/2, right? Okay. Now, as we get to D, okay, we kind of worked our way through A, B, and C. We're ready for D. You see multiple parentheses. What do you guys know when you see multiple parentheses? You're going to start on the inside, right? So start with sine of pi over 3. Now, unfortunately for the duration of today, because I have people quizzing, you're not going to have the sideboard to refer to. So you're going to have to flip back in your notes to see how well you had it memorized. Thoughts on sine of pi over 3? No.
Square root of 3 over 2.
Okay, square root of 3 over 2. Pi over 3 radians is equivalent to 60 degrees. But I'm asking what is the sine of pi over 3, which would be equivalent to saying what is the sine of 60 degrees. Okay, so according to our chart, the sine of pi over 3 is square root of 3 over 2, correct? Now realize, that wasn't an inverse trig function there, was it? That's just what was the sine. So now, we know that that's square root of 3 over 2. So now the question becomes, what is the sine inverse of square root of 3 over 2? Now I will say, if you recall a little bit from yesterday, I was always reminding you, check your domain. Is this sine inverse? Is this a valid domain? What did our domain have to be? Between -1 and 1. Is square root of 3 over 2 between -1 and 1?
Yes.
It is. Okay, so that is your domain. Make sure it's good. Hey guys, what do you think? Sine inverse of square root of 3 over 2.
I don't remember what that is. I'm not sure.
Okay. So when we talk sine inverse, remember our answer is going to be an angle. So at what angle does sine equal square root of 3 over 2?
Pi over 3.
Pi over 3. Yes? According to our chart, pi over 3. What do sine and sine inverse do to each other?
Cancel each other.
They're inverses, right? So they're going to cancel each other out. Okay. Sine and sine inverse, they're inverses. They do essentially cancel each other out. Now, the key is that pi over 3 also has to be in the range for this to work seamlessly like it just did. And if you recall yesterday, from our ranges, is pi over 3 in our range? It is. Remember, you can look on the back side. From negative pi over 2 to positive pi over 2 is where our range answers are. And pi over 3 is in that area, isn't it? Okay, so that has to be true. Okay, so your answer is just pi over 3. Easy enough? Okay. So let's look at E. Sine inverse of sine of 5 pi over 6. Where are we going to start?
The inside.
We're going to start on the inside. So first thing we have to do is figure out sine of 5 pi over 6. Now, where is 5 pi over 6?
Second quadrant.
Yeah, okay. So 5 pi over 6 is over here, isn't it? Okay, it's in quadrant 2. Think about this. What is the reference angle for 5 pi over 6? Because we have to reference this to pi over 6, pi over 4, pi over 3 from our chart here. So this kind of goes back to what we did in our previous lesson. 5 pi over 6, what is my reference angle there?
It'd be 5 or 6.
Yeah. In other words, remember when I say reference angle, I'm asking how far is it from the x-axis? And it is pi over 6 from the x-axis, right?
Yeah.
So when we say sine of 5 pi over 6, remember that is fancy speak for saying what is the sine of pi over 6 in quadrant 2? What is the sine of pi over 6 according to our chart? I'm pointing to the chart not filled in, so flip in your notes.
1 over 2.
Okay.
And it'd be positive within the second quadrant.
Okay. Sine of pi over 6? 1/2 according to our chart, right? What do we know about quadrant 2? All students take calculus. So that's a sine quadrant, so it's going to be positive, yes? Okay. So now I'm asking myself, whoops, what is the sine inverse of 1/2? So when I say sine inverse of 1/2, sine inverse at what angle
So it'd be 5 or 6.
does sine equal 1/2? And according to my chart, at pi over 6, sine will equal 1/2, correct? Now, is pi over 6 in the accepted range value?
Yeah.
It's between, remember, go to your half circle. Pi over 6, it's one we must have talked about yesterday. It's between negative pi over 2, positive pi over 2. So we do have a good range value here, and we do have a good domain value. Now, okay, compare part E back to part D. With part D, sine inverse and sine just undid themselves. And you got what the input originally was. Here, sine inverse and sine, they undid each other, but why couldn't we just put 5 pi over 6?
It's not 3.
Yeah. For inverse, you have to be on that side, right? 5 pi over 6 is here. Okay, so just be aware. Don't automatically, oh, sine inverse sine. They're going to undo themselves. It's just whatever I put in. You have to think about a little bit more than that. Am I making sense at all? Maybe a little. Okay. Okay. Sine inverse of -1. Now, first of all, is this a good domain?
Yeah.
Yes, because my domain is -1 to +1. I'm trying to get you guys in the habit of checking. I'm guilty of forgetting to check sometimes too, but that is a good domain, yes? Okay, so there's going to be an answer is what I'm telling you here. Now, with this in mind, normally I've been saying, okay, at what angle does sine equal -1? And I'm trying to train you guys to go to your chart, yes? Well, what's the problem with that?
Chart.
Yeah, does sine equal 1 or -1 on the chart?
No.
It doesn't. Okay, now, special angle here, guys. We've done this. When do a lot of 1s and -1s and 0s pop up?
When it's on its axis.
When it's on an axis, yes? Remember our quadrantal angles? I'll throw them out in degrees, but 0 degrees, 90 degrees, 180, 270 degrees. We're going to talk radians, of course, but
It would be on the bottom part of your y-axis because sine is the y value, and so -1 would be your y value.
okay. So first of all, do we remember that sine is the y value, right? Cosine comes first, that's x. Sine comes second, that's y. The ordered pair down here on 270, if you will, to just throw it out in degrees, is 0, -1. So what do we have right here? This is my sine value. Okay? So, at what angle does sine equal -1?
270 or 3 pi over 2.
Okay? So, I'm going to stick with radians. Now, radians is 3 pi over 2 for 270, yes? But is 3 pi over 2 in my range? It's not.
No.
So, we have to give a different answer. Think about this, guys. I'm going to flip to the back of your notes to that range chart. Where is 3 pi over 2? 3 pi over 2 is here, yes? What's another name for 3 pi over 2? Negative pi over 2. So here's the deal, guys. You tell me 3 pi over 2. I get that you're at the right spot, but I technically have to count it wrong. I know, it's annoying, but it's the rules of how the inverse trig functions work. Okay? So, I'm going to say that this answer is negative pi over 2. And the reason being, while this guy is technically correct, he is not in the range. Okay? Okay, that was a really sloppy R. Whereas negative pi over 2 is in the range. Okay? And I guess I didn't show it. How could you get 3 pi over 2 to that? You could subtract 2 pi, right? I didn't show that, but... Okay, guys, are you getting some of the catches here? The basic idea of inverse trig functions is very basic. It's very easy, you know, at what angle does sine equal this? But there's some catches along the way. Okay, questions here. Okay. Let's go for the fun section for a moment. Example 2 says use a calculator in radian mode to evaluate these inverse sine values. Now, keep in mind, folks, these are the ones we can't do on our own. We have to have the calculator. When it's on A, when it says sine inverse of negative 0.81, is that on our chart? Is that one we know? At what angle does sine equal negative 0.81? That's not one we have. Okay, so grab your calculator, everybody, please. And let's make sure we know how to do an inverse trig function. I have confidence you guys can figure it out, but I want to make sure we're all in the same boat here. Okay, have you figured it out? Or are you waiting on me to even try?
Negative 0.9441521152.
Okay, I have 3 decimal places written down in my notes, but yes. Did you guys get what Logan got?
Yes.
Or have you tried yet? You know, the negative 0.994944. 944. Okay, now, what'd you figure out, guys? How do we do an inverse trig function?
Second.
Okay, that little sine -1, cosine -1, tangent -1. Those are your inverse trig functions. They're not reciprocals. Okay, they're not reciprocals. But you just hit it. Notice it pops up the sine inverse, and you type in what you need to type in. The negative 0.81 And there is the answer that you guys should have gotten, the negative 0.944, so on and so forth. I just have 3 decimal places written down. So negative 0.944. And notice, that's a radian answer. Okay, radian answers are just going to appear in decimals. Okay? Give part B a try. I'm assuming everyone got the calculator to work because no one's asking questions or complaining. Sine inverse of sine of 3.49 pi is?
Negative 1.539.
I agree. Did you guys get it? Okay. Negative 1.539. Beware. You're going to use the calculators when you're asked to use the calculators, right? You give me a decimal answer like this on something where it's without a calculator, it's an instant going to count you wrong. Because that means you use the calculators on some place where you're supposed to be using the chart. So example 1, those weren't calculator questions. I'm looking for, using your chart. This says use a calculator. Okay? You do have to pay attention to mode, because if you're in the radian or degree mode, it would shoot the answer back in degrees. Okay, which is sometimes interesting and helpful, but not what I'm looking for. Okay, are we good there? Okay, we start with sine. It's the most common inverse trig function. You got the basics out of it. Now we're going to take the second half of this page and we're going to look at inverse cosine and inverse tangent functions. Except I got to get to the right page here. Okay, so similarly, they can be written 2 ways. Cosine inverse, so with the negative 1, or arc cosine x. Okay. Same thing with tangent, tangent inverse x, or arc tan x. So 2 different notations, still both exist. Now, okay, inverse cosine function. Pay attention here. What do we have? Inverse cosine function has a domain of negative 1 to 1. Sounds familiar, doesn't it? Note, it even says, just like sine. Note, here's the biggie. A range of 0 to pi. Okay, where's 0 to pi? You think about your quadrants. 0 to pi is what? Top 2 quadrants here? From 0 to pi. So this is the big difference about arc cosine. Its output values have to be in quadrant 1 or 2. Not quadrants 1 and 4, but quadrants 1 and 2. So that's the big deal to watch out for there. Okay. Inverse tangent function. Here's a big difference. Domain of negative infinity and positive infinity. So inverse tangent function, the one where anything works for the domain. Your range, negative pi over 2 to positive pi over 2. Similar to sine, but is it the same as sine?
It doesn't include them.
Right, okay. If you look back up at sine inverse, pi over 2 and negative pi over 2 were included as options. This goes up to pi over 2 and negative pi over 2, includes everything up to them, but does not include them. So if you flip to your backside, notice the only difference here is, okay, yeah, this is pi over 2 and negative pi over 2, but you see x is there as kind of your reminder that those are the one pieces that don't matter. Okay, so yeah, you can still think of this as pi over 2 and, whoops, negative pi over 2. You just won't include those values as options. Okay. Ready? Let me flip back to our examples and see what we can do. Notice, find the exact value without a calculator. So anytime it says that in this chapter, think chart. Okay, go to the chart, your unit circle, not the calc there. I'm not looking for decimal answers. Okay? Okay. So, example A. We're going to talk cosine inverse. First of all, let's double check our domain value. Is this a good domain value?
Probably.
Okay, well, domain for inverse cosine has to be between -1 and 1. Is it? It is. If you do square root of 2, that's 1.4. And when you divide by 2, you're going to be at like, what, 0.7?
Yeah.
So it works. Okay? And here's the thing, guys. Square root of 2 over 2. That's a value you should be familiar with. I don't guarantee you guys wrote it on your quiz there because I gave you options. But this is where I've said, you know, on that quiz, I said on certain boxes, I don't care which answer you give me, but be familiar with both. This is why. Okay? Okay, so that's a good domain value. So we're asking ourselves, at what angle does cosine equal negative square root of 2 over 2? Now, here's what I would think, first of all. Forget the negative for a moment. When does cosine equal square root of 2 over 2? Check your chart out. At what angle is that happening? Pi over 4, yes? Okay, so that's what I want you, that's what I need you to do there. Okay, so we're going to think pi over 4. But what's the catch? But you need a negative quadrant. Okay? Now, think about this. Pi over 4 is there, right? But that's a positive quadrant. What are my options for inverse cosine? My options are 0 to pi. Am I allowed to give anything down here?
No.
No. Okay, so what negative quadrant am I using?
Quadrant 2.
I'm using quadrant 2. What angle is that in quadrant 2? 3 pi over 4, yes. So what's my answer? My answer is 3 pi over 4. Okay? Now, what's different about this? Yesterday, with sine inverse, we could have just said negative pi over 4, right? When it was sine inverse, you're in the negative quadrant, we can just put a negative in front of the angle. With cosine inverse, I can't do that. Okay? With cosine inverse, I have to figure out, okay, what is the pi over 4 angle over in quadrant 3? Or excuse me, quadrant 2. And that pi over 4 angle is 3 pi over 4. Okay? So this is where things get a little tedious. You have to be careful. Questions on this one? Have I explained myself? I didn't write it down, but we've talked about it. Does my range value check then? It does. Okay. If you had said negative pi over 4 by mistake, you would find that that doesn't fit our range because our range is 0 to pi. Okay. Good. Okay. Ask questions if you have them. Tan inverse of square root of 3. First of all, is that a good domain? Yes, because my domain for tan inverse is anything, right? All reals. So, you're asking yourself, at what angle does tangent equal square root of 3?
pi/3.
Pi/3, straight from the chart. Is pi/3 an acceptable range value?
Yeah.
Tangent inverse is your range values are negative pi/2 to positive pi/2, which are the right two quadrants, right? Negative pi/2 to positive pi/2. So you're good. You're in quadrant 1 there. So answer of pi/3. Okay. C. Cosine inverse of cosine of negative 1.1.
Well, you think it's probably pi/6. We don't have an official.
Okay, so this one's not on the chart, is it? When we start talking about cosine of negative 1.1, I mean, because officially what? I'm going to train you guys to look at the inside first, right? But do we cosine of negative 1.1? We have pi/6, pi/4, pi/3. If you want to, you can talk about the quadrantals like pi/2, pi, 3 pi/2. I don't have a negative 1.1. Okay? Now, here's what I want you to consider. Notice what's going on out here. Cosine inverse and cosine. What are cosine inverse and cosine going to do to each other?
Cancel.
Okay, they're going to undo each other, yes? Now, with that in mind, there is still a catch though. Okay? So, they're going to undo each other, but if they just strictly undo each other, what are you going to tell me the answer is? Negative 1.1. Now, negative 1.1 is some angle. What quadrant is negative 1.1 going to be in? So what? 1.1, is that similar to pi divided by 3?
Probably, yeah.
I mean, I know this is a non-calculated problem. I'm just using it to, okay. Could we argue, it's similar to negative pi/3, yes? Now, the reason I'm asking this, where is negative pi/3?
In the first quadrant.
Positive would be in the first quadrant, but negative 1.1
Quadrant 4.
is going to be down here, yes? So while we use negative pi/3 to think about it, negative 1.1 is going to be up here, or down there. Well, here's the deal. This is a cosine inverse problem, folks. Where are cosine inverse answers allowed to be? Quadrants 1 and 2, yes? So, here's the idea. What is the equivalent angle up in quadrant 1 going to be?
1.1.
Positive 1.1. Okay? So where am I trying to lead you to the answer of? It's going to be a positive 1.1. Okay? This is similar to part E from above. Okay? It's similar to part E from above because we have to get in the interval of sine inverse. Okay? Well, at that time it was sine inverse, yeah, cosine inverse now. So I'm going to say similar to part E from above, just for reference there. Okay? We had to get it in the cosine interval, or the cosine inverse interval. And the cosine inverse interval is 0 to pi. So it's all about making that range value work. Okay? Now, if you don't believe me, could you plug this into your calculator and check yourself? You could. And it's going to pop out the 1.1. Okay? That's a toughie, but let's look at D and E real quick. Part D and part E, that is. Okay, D, tangent inverse of 0. First of all, is this a good domain value?
Yeah.
Inverse tangent has all real numbers pretty much for your domain, so that's good. Now, okay guys, here we go again. At what angle does tangent equal 0?
1v 1y over x is 0.
Okay, so tangent equaling 0 isn't on my chart, is it? Zeros are your quadrantal angles, yes? Zeros are your quadrantal angles. Tangent, if you recall, is y over x. When is a fraction 0? When 0 is where?
Y.
On top, right? So when we talk about y being 0, and x could be anything. I'm going to say plus or minus 1, right? It could be positive 1, it could be negative 1. Okay, at what angles is that happening?
At 90 and 2, or 70, pi over 2, or negative pi over 2.
Check again. When is y 0?
At 90 degrees or 270.
Check again. If I do at 90, this is the ordered pair 0, 1. So y is 1. At 270, this is 0, negative 1. Are those the pieces I want? No. Y is 0 at 180 and at, whoops. Okay. And at that point, I've just written in all forward pairs. But when is y 0? At 0 and 180 or at 0 and pi, yes? Are they both answers? What are options for inverse tangent? Inverse tangent range options are only, yeah, they can. It's the right half. Anything from negative pi over 2 to positive pi over 2. Does pi fall in between negative pi over 2 and positive pi over 2? No. But what does? 0. Okay? So I'm looking for the answer of 0. I'm not sure I've sold everybody on that one. Is there a question I can answer? Okay. Let's look at one other. Cosine inverse of negative 1. Well, guys, when is cosine equal to negative 1? Is cosine and 1 on my chart at all? No. It's going to be another one of my quadrantals, yes. When is cosine negative 1? over here at 180 because the ordered pair is negative 1, 0. Remember, an ordered pair is cosine, sine. We don't really want to say 180 though. What do we want to say? Pi. Is pi an option? Yeah, my range is 0 to pi. It's at the very edge, but it is an option. Okay, and I never checked the domain on that one. Domain was supposed to be negative 1 to 1. That does work. Okay, guys. Your homework is page 378, 1 through 20, and 23 to 32. Okay? Pay attention to directions. Do they want you using the calculator? Do they not want you using the calculator? Do they want you to give your answer in degrees? Do they want you to give the answer in radians? I think you do have a few calculator ones that want you to use degrees. So obviously just change your calculator mode from radians to degrees. But if they say find the exact value, that's no calculator. Okay? If it says it will tell you to use a calculator when they want you to do that. Yeah. Okay? Okay, guys. Get this done for tomorrow, please.